Welcome everybody. You are at the cargo glider training. We will be giving everybody about 1 minute to come on with us and then we will get started. Good afternoon everybody. My name is Jeanette Espina and I'm the director of the Imperial Valley Mesa. Welcome everybody to our cargo glider training. Let's get started. Okay, to tell you a little bit about what we're going to be doing for the next hour. So we will be starting with a competition objective for those of you that are new advisors and it's your first year with us in Mesa, so that you understand what the objective to our glider is this year. And after that, for those of you who are returning, I will go through some of the changes that we made this year to make the glider competition just better overall for our students. I want to really point out that we really listened to all of your questions and concerns about the competition last year. So I hope that you like some of the changes that we've made for it this year. We will also then share a competition video with you. It kind of puts everything together so that you can share that with your students. And so you can see from launching to every aspect of it, how it works. We will then also spend a little bit of time on the curriculum that's available to all of you. I'll show you how to navigate it and what you can find in it. And then we will build a simple glider on the spot as a starting for the project with your students. We will go very heavy into glider concepts, and then that will be it. We'll go into questions and surveys at the end. Ready? Here we go. The competition objective for middle school. We have 6th grade independent, and then 7th and 8th grade can work together. Students will design and construct a glider with a payload of 2 ping pong balls that, when launched, flies through the air and goes over an obstacle. The longest distance is the objective for middle school. High school is 9th and 10th combined, and then 11th and 12th combined. Students will also design and construct a glider with a payload of 4 ping pong balls that, when launched, flies through the air, goes over an obstacle, and then lands on a target. So accuracy is the objective for high school. An engineering lab book will be due with this project, and you should check with your center on how that will be turned in. In terms of materials for this project, any materials are allowed with the exception of hazardous materials, remote control devices of any kind, and additional power sources. So let me explain a little bit of what you will see when we're demonstrating our gliders. You will see a lot of balsa wood today. I do want to let you know that we are actually currently trying out to 3D print a glider from scratch, but we do not have it ready to show you today. We did actually in the summer work with a lot of different materials, cardboard, some plastic, different types of materials to see what would work best. And in our research here, I'm not saying that we're 100% correct. In our research, the balsa wood that we are using is just what worked best for our project. But again, letting you know that it does not only have to be balsa wood, and we would love to see other materials being incorporated. Again, for those of you that are new to us, here's a picture of what the obstacle looks like. So the glider must fly over the 5-foot obstacle and must stay within the 10-foot width of the obstacle. For gliders that go outside this boundary, the launch is considered a mistrial. And again, we will see all of this in a video shortly. Here is the launcher. So it is a simple table, and the clamps and the rubber band, everything that is needed is very specific, and it's in the rules. And again, you can check with your center on how you can obtain these things. Okay, now to explain the payload a little bit. The middle school requires 2 ping pong balls, and the high school requires 4 ping pong balls. Teams cannot change the shape of the ping pong balls in any way that includes crushing, cutting, or drilling. The balls may be glued, string can be holding them, tape can be holding them, as long as you can see the rating on the ball. The ball must have a 1-star rating and the 40 plus symbol on it, as you see in these pictures. The reason for that is the weight of the ball. We want it to be consistent all across the state. You would be surprised at the variations in weight between ping pong balls. So again, to make it the same across the state, it will have the 1-star rating and it will have the 40 plus symbol on it, as you see here in this picture. And for the launching hook, the glider must contain an easily identifiable prominent feature on the fuselage that adapts and connects with the launcher adapter. The adaptation must be identified by a red dot. To explain this a little bit more, it does not have to be an actual hook. It can very well be made out of balsa wood. It actually works better when you make it out of balsa wood, because then you're not weakening the fuselage by screwing something on it. We will show you in the next few minutes how to make a simple hook out of balsa wood. Okay, now for those of you that were with us last year, I'm going to quickly go over some of the changes that we made to the rules, again, because we really listened to you and really put a lot of work into this in the summer to make this competition greater than it was last year. So to start, the distance from the table to the obstacle has increased from 11.5 feet to 17 feet. The high school target has changed from 23 feet to 34 feet from the table to compensate the distance from the obstacle. The number of ping pong balls have decreased. So last year it was 8 for high school, we're doing 4. And then middle school had 4, and now we're doing 2. So again, high school has 4 ping pong balls, middle school has 2 ping pong balls. We have also included a really simple way to support the table, because if some of you recall, as you moved the rubber band back to launch, it was buckling a little bit. So we're showing you a very easy way to strengthen that. And then we're going to show you how to prime your rubber band for optimal launch. And then we also created a very simple adapter that is just a lot easier when the kids are launching. And I'll show you all of that in pictures coming up. The reason that we moved the obstacle from 11.5 feet to 17 feet. Most planes did not go over the obstacle at the distance of 11.5 feet due to the glider having a small angle of incidence. Pushing the obstacle back will make it easier for the gliders to go over. As I mentioned earlier, there were instances of the table buckling in the middle. Specifically, our table here is a folding table. Just for a lot of us have very minimal storage, so that's the table we were using. So as the rubber band was being pulled, it could buckle kind of upwards. So to solve that, here's a very, very simple solution. These are little pieces of PVC pipe. Again, everything is listed on the rules with 2 screws. And if you put one on each leg and literally push the screws in with your foot into the grassy area, it gives it all the support that it needs. We also have something else for a hard surface. So again, this is still PVC pipe, everything listed on the rules, but this just gives it the support it needs if you're launching off of a hard area. Okay, and for the rubber band usage, and again, this will be demonstrated in a video upcoming, or coming up. We actually did a stress test on the rubber bands on site. You can see our little tool here that we used. What that test determined is that you need to first prime the rubber bands. You have to pull it back 15 times. And then from launch 16 to 70, it's pretty much consistent. So again, so that the rubber band kind of, gets to where it needs to be, you would pull it back 15 times. And then launch 16 to 70 are optimal for that rubber band. And then after the 70th use is when we would change out that rubber band. Another very simple but kind of ingenious idea that our staff here on site came up with is to 3D print a very simple launcher adapter that you can see here in the middle picture, and I'll show you a close-up in just a second. It basically allows for the glider, for the hook that you create to attach onto that. And it's a smoother launch. It actually helps the glider not get stuck on the rubber band like it was doing in the past. So let me move on to the next slide to show you. We actually went through several variations, and this last one works just perfectly. And again, it's on the rules. You can easily have your centers printed out. We did offer the centers as well if they do not have a 3D printer available, that we can print a few on site. So it's just a very simple way to ease the launching of the glider. Okay, now that I went through all of that, we put a very nice video kind of demonstrating everything I just spoke about. And by we, I mean we have a very talented person on staff that I have to give credit to. Minero Villalpando is our program coordinator, and he makes the most beautiful videos, as you will see. And so please enjoy this video. Again, you will have access to all of this. We will put all of our presentation, all the videos that you will see will be on this presentation. We'll put it on the chat coming up shortly. Enjoy this video, and then we will go from there.
So the first step is to locate the official adapter and where you want it placed on your glider. Once you identify both, you're going to line them up. You can start pulling back, create some tension, and make sure it's placed correctly. Then we have a few adjustments we can make. We have direction, we have pitch, and we have roll. Once you're ready to launch, you will pull back from the fuselage or the tail wing closest to the fuselage for maximum strength.
Okay, I hope you enjoyed that video. I think it's a great resource to have for you to share with your students. And again, we will include all of these slides to the chat, and they will have all the links for all the videos and everything that we're going over. And as well, you will receive an email with this entire recording in the next few days. So let's move on to the curriculum. I want to share with you briefly what is available to you. If I clicked on this link that takes me to the Canvas site where our MESA Advisor resource site is, I'm going to click on modules. As you can see, all of our MESA Day projects are on here. All the rules are on here. But what I really like is that you have curriculum for most all of our projects. So I will click on Glider General Curriculum. And as you can tell, there are several bullet points that you can click on here. I will start with Engage. And there are several introductory glider activities that you can do with the kids to just get them started. As simple as making a paper plane to a little bit more advanced things. But I think it's a great way to start the glider curriculum with your students. You get them to do a simple activity like this. You then move on to some of the concepts that we will be discussing shortly, and then they can begin their glider. I just spoke about the curriculum and maybe doing an entry-level project with the kids before they build their actual glider. We have a simple glider how-to coming up just after me. It's a great introduction on some of the concepts for the kids. It shows how to build a glider, and then from there they can move on to their actual competition ready glider. So please enjoy the next video.
So we're going to start off first by cutting our fuselage at 10 inches. Using the ratio, this means that our wing has to be at 10 inches. And using the same ratio again, it's half that length, so it's a 5-inch tail wing. In order to attain symmetry, I like to do some lines to help out. So right here, as you can see on the fuselage, we got 3, which indicates a third mark and a center line. And both center lines for the wing, and just one center line for the tail wing. Now that we have the lines marked, I'll show you how to place them. We want to line up the center line of the wing to the 1/3 mark and the fuselage. And then the center line with the center line. And now you just gotta line up 2 lines, and that's how we place. Tail wing is a bit easier, it's just both center lines, you line them up, and that's how it should be, towards the rear of the fuselage. But before we put it together, now we gotta talk about airfoil and angle of incidence. This piece provides the airfoil, and at the bottom we have the angle of incidence, which provides the angle. And this one is ideally placed between the wing and the fuselage. And this is how it would look. Now we have everything put together. This is how it looks. Right now we're going to do a quick test to make sure we're symmetrical. We're going to check our 90-degree angles. As you can see, the tail looks pretty straight. And now our wing seems to be straight as well. Now you can see I added some more airfoils to keep the curve throughout the whole wing. This is essential as to create more lift. There is the angle of incidence. Now, in order to increase stability, we're going to add a fin in the back. This will help it fly more in a straight path, kind of like an arrow. Now it's all placed. Now we're ready to do the finger test for balancing. So as seen before, we're going to put it in the center right there. And as you can see, we need some weight at our nose. We add it at the nose just to keep our total weight low. And as you can see, now that we try to balance, it tips now to the side. Now we just add a little bit more mass on the opposite side, furthest from the fuselage. As you can see, now it seems to be way more balanced. Now that we have a new adapter, we'll show you a quick tip of what we believe is a good way to attach your glider to the actual launcher we have. So you just cut 2 pieces of the fuselage as shown. It's a really good shape that will really grab onto the launching mechanism. As you can see, this is how it should look, and that's how it grabs on. And now once it's glued on your glider, it's ready to be launched.
And that was a simple video for you and your students on how to build the glider. Now we are going to get into the physics of what it means to build a glider. I want to introduce Luis and Paola, which are two of our undergrad staff. Brilliant. I'm so lucky to have them on our staff. Again, they spent most of the summer doing a lot of research and building a lot of different gliders to come up with the next video for you and your students. So let's take a few minutes to watch and hopefully really get a fundamental understanding of how to build the gliders and what lift is and drag is and so forth. Here we go.
Today we'll go over some few concepts and tips that will hopefully help you out with this competition.
To build a glider, we first need to understand how it balances itself in the air. Some of the forces that it's going to experience are going to be thrust, drag, lift, and weight. These forces are going to be shown in the image below.
The most important force is lift because it is the force that counteracts the weight of the glider and keeps it in the air. A way to manipulate it would be with the airfoil or the angle of incidence.
When we talk about airfoil, we refer to the shape and arc given to the wings of a glider. By adjusting the arc, we can create more lift. However, it is important to consider that when we create an aggressive arc, we are also creating drag. In the following diagrams, we will show you different variations of airfoils.
Needless to say, moderation is crucial, especially when we talk about the angle of incidence. The angle of incidence is the inclination of the wings in relation to the fuselage.
The center of gravity is ideally placed at the center of the wing. This is important because it helps reduce torque forces in any direction, which cause the glider to flip.
To ensure that our glider is balanced, we will have to do the finger test. We will place our finger on the center of wings and check for balance. If it tilts a certain way, we would put weight on the opposite side until it is balanced. In our case, we'll be using clay, and it is preferably placed at the tip of the fuselage.
Although drag is an opposing force, it ensures that you have a stable flight. To be more specific, you will achieve a straight path. Now, when you locate most of your drag on the back of your glider, it ensures that your tail follows your nose. Now, let's not forget that too much drag will shorten your flight distance. For any object in the air, any square or sharp edges are usually not your friends. Rounding your edges will help you achieve a smoother flight. Some tips to make your glider more aerodynamic would be to round your edges like so.
Typically, we want the fuselage and wings to be the same length and our tail wing to be half that length. Then we would place the wings at the 1/3 mark on the fuselage and the tail wings towards the rear of the fuselage. Then, in order to attain symmetry, we can use an imaginary line going through the fuselage and make sure both sides are mirrored throughout. This ensures that the forces are proportional. For a more stable flight, try to place your load at the bottom of the glider as it will prevent wobbling, fighting the urge to flip over. The balls also come with some surface area which create drag. This drag is inevitable, but we can use it to our advantage by placing it far from the nose. Another way to decrease drag caused by the load is to line them up in the lines as in a way to reduce cross-sectional area. Another way is to wrap the balls in a way that helps it cut through the air.
There are a few other ways to improve stability in our glider, and here are some examples.
The first example we're going to talk about is the winglets. As you can see on either side of the wing, we have the winglets. Those help with the straight path. Then towards the rear of the fuselage, we have our tail wing right there, which helps also with the straight path. And right there you can see the airfoil that helps in order to reduce drag and have more lift. Now we're going to go into something called a dihedral. As you can see, the wings are bent upwards. This helps balance the load that it has.
We want to emphasize that before you launch, it is important that you have a good center of mass and a symmetrical glider.
This is crucial because you want a predictable flight to be able to diagnose any problem you may confront. Also, avoid any unnecessary crashes.
And now that we have a symmetrical glider and a good center of mass, then we can start launching. One of the first problems that you're going to encounter are going to be when your glider pretty much tips like this or does a backflip. To counter this, we can add more weight on the front or create more lift on the tail.
It's also important to note that you don't have an airfoil or an angle of incidence that is too aggressive. Now, if your glider keeps crashing down, a good solution would be to try to remove some weight from the nose and hope that fixes the problem. If not, you can look back to your airfoil or angle of incidence and probably increase it.
Now, if you find yourself making excessive adjustments, you might need to reduce the total weight. Finally, if your glider is turning, you can simply add more weight to the other side to fix this problem.
Another solution could be maybe adding more stability components as a bigger tail, or maybe some winglets over here by the wings.
Next, we will answer some of our most frequently asked questions. The first one being, where do I place my hook?
For an adequate launch, you would typically place it under the center of your wings, and it will be launched parallel to the table. But if you push it back a bit more, you can probably get a better flight as it will catch the air better.
Our next question would be, how do I adjust my glider to weather conditions?
So our launching mechanism has a few adjustments available, such as direction, pitch, and roll. We will now go over some tips for middle school students. To remind you guys of your goal, you would want the maximum flight distance possible. And to obtain this, you would want to reduce drag as much as possible, add many stability components to get a straight path, and when launching, get an efficient launch by reducing friction and get all the power transferred into your glider.
Now for high school, remember that your objective is to overcome an obstacle while carrying 4 ping pong balls and landing on a specific target. Accuracy. Some of the tips that I have for you would be to not be afraid of lift. Remember that you're carrying a heavy weight and it will help you, gain height. Another tip that I have for you would be to launch the exact same way every time. That way, you're going to be eliminating variables. And lastly, I want to recommend that you build a very sturdy glider because remember, the heavier it is, the faster it's going to crash. And you want to spend less time fixing your glider and more time adjusting for accuracy.
Thank you so much to Luis and Paola. I've also included a slide here for additional resources, a lot about what we just discussed this evening, and a few other things. You can just click on any of those links.